first thank to Giulio because I asked him some weeks before the impressions about Japanese tour, but it was really nice and interesting. And after that, I have no chance to be as much as he was interesting, and really, it
Thank
was
you.
really nice to
It's a
see your
pleasure.
impressions
Yeah.
and your ideas. And the last point that you stressed, I would like, before beginning what is my theme today, I would like to connect something that was the last point that you stressed about the heritage of the old or of the concrete buildings, because Elisabetta the day 2 days before was telling something like that. Often, also in Italy, it happens more and more that the excuse of the seismic retrofitting becomes an excuse and is often just something that covers other purposes and brings to decisions to throw down buildings that have to be evaluated more carefully, and often buildings that have social or cultural value that is not so much considered. So we have always to keep that in mind. And I think one of the purposes of Concreto is this one. From my point of view, I'm lucky to be engineer and architect, but often uh, for professional problems, I deal more with the seismic part. And this project has been for me something useful to change a little bit and to shift a little bit my point of view and to be more careful and more sensible to the theme. Well, what I'm going to show to you in a few minutes is a very quick overview of some digital tools that are coming out and are being more and more integrated between them that will help in the next years to manage better the life cycle of concrete structures. And it's something that is going really fast. My time is too short, but it's just, I repeat, just an overview to help you understand where it is going and what is happening, especially related to the concrete structures. Um, First of all, we all know, because we are immersed, and especially you that are young people, you are immersed in the digital revolution that is coming out day by day, especially with the AI. And what is happening is really, really quick and hard to understand, even, especially for people like me that have a certain age. But what is normally happening is that we have this shift from the periodic to continuous. That is the typical changement that brings from what was not digital to the digital measurements, the convergence of the technology, because all the pieces are being more and more put together and connected more and more, and are becoming quite a unique environment that brings together all the pieces. And this brings a very higher value of in terms of efficiency of these systems, how they can be used, and how can be every piece of these digital tools bring to BIM methods or to systems that can be well connected between them and be at the end something useful for the everyday life of a technician, of the retrofitting process, and of every one of us, in each of us in its professional role. So the categories of digital tools are really a lot. Here you have just some of them. It's just some highlights about the embedded sensors, about the digital connectivity of different systems that can give us data and information about concrete structures or concrete parts of a structure. The robotic inspection as another important new tool. Also the robotic demolition, and all these, how they are put together and helped and integrated by the AI analytics that permit us to have to collect the data, to analyze the data automatically, and to have instructional and concrete and real instructions how to manage the maintenance of a structure in time. And also something about the smart digital materials that are coming out in the same way and are more and more connected with all the rest. First of all, the embedded sensors in concrete is something that is related, of course, to the sensors. The sensors are something quite old in technology generally, because there are more than 80 years that sensors are used normally in a lot of places, in a lot of environments, and there is nothing new about the sensor. But what is new is that they are becoming always more and more smaller. They are becoming more and more cheaper, and they are becoming more and more smarter. Okay, because sensor, every one of us now in everyday life we met sensors when we have the automatic opening doors of a supermarket, or the light sensors, or the presence or alarm sensors, etc. We live with the sensors already, every one of us. But what is happening is that the sensors become smaller, smarter, and cheaper, and they are put together with different digital systems that bring us to a point where we can collect a lot of data, and all this data can be used to make better and earlier decisions, to reduce, of course, destructive testing, especially in concrete existing structures, and to have a better quality control over the structures that we build or we have to manage if we talk about existing buildings. Normally, the idea of the integration is just that one of beginning from the sensor and then to an edge or node collection, and then pass to a gateway that transmits and puts to a cloud storaging system of the data. And of course, at that point, I can analyze and I can have predictions about the structure, how the structure is behaving, and how I can manage and plan the maintaining operations in the future. So everything is connected by the technology itself. This is the real new point about the technology, is the collecting process that becomes quicker and quicker every day. Because I repeat, the sensor in itself is something that we already know from a lot of years, technically. But what is happening new is that the sensor becomes something really easily connected with all the rest. Here you see just some of the commercial solutions that there are coming out, but here it's really difficult to maintain the point, because every day, every week, and every month we have new materials, new systems, and more integrated systems that bring to a better management of the data that we have from the sensors. Just to have an idea how it works, just let's take a look to this very short video.
During the concreting process, the strength of the concrete determines the time of striking, that is, the time when you can safely remove the formwork and start the next cycle. As such, the overall progress is dependent on the concrete strength, and this strength is directly related to the hydration temperature. Hydration is the chemical process by which cementitious materials stiffen, solidify, and harden. The reaction begins when the cement comes into contact with the batching water. Concrete goes through 4 stages while changing from liquid to solid state. In stage 1, the cement particles are separated from the batching water. Hydration begins. This happens quickly at a high temperature. Thereafter, in stage 2, the concrete hardens slowly but steadily at a low temperature development. In stage 3, the temperature increases again. And finally, in stage 4, the concrete continues to slowly harden until it reaches its final state. The concrete strength can be determined in real time, thanks to the Perry Insight construction temperature sensors. The prerequisites for this are the calculation formula and information on concrete maturity, sourced directly from the concrete manufacturer or determined by testing concrete samples. On the construction site, the temperature in the concrete is measured using the temperature sensor. The values determined are sent straight to the cloud. The measured temperature is used in the calculation together with the information of the concrete maturity in order to determine the compressive strength of the concrete in real time. The result, when the concrete reaches the required compressive strength, the formwork can be safely removed to begin a new cycle, hence saving costs.
Just keep in mind that this video, for example, is of one of the systems that are present in the commerce of Perry. Just to have an idea, Perry is the enterprise, the company that has dealt with all the tallest buildings in the world. The Burj Khalifa, for example, was made with Perry formworks. It was in concrete, and it was made with the Perry. With just to have an idea, the biggest companies, of course, are working more and more in these systems because they are related to the plan and to the time. This is what you see here is another different. It's called Smart Raw, and it is the same idea, that of putting sensors inside the concrete mass and then measuring and having continuous data from these sensors. It is possible to see and to understand in real time the evolution of the mechanical resistance of the concrete. That is really important because it means a different management of the process, especially in particular places. Hilti also is another big company that is working more and more on different kind of sensors just to put them inside the concrete and to transform the material in something that is connected in the digital sense of the term. That means that you can know your concrete from the first day you put it on place till the entire life of the concrete sometimes. And this is really important because it brings to a lot of advantages, especially in complex constructions or construction sites, and infrastructure especially, but not only. Here you see another one, of course, called Cure. And the sensors here can be both used with auto data collection in converged gateways, that means in short terms, in short distance. And also you can put a long range network that works also in big mass, in big forms and volumes of concrete. That means that even inside, very deep inside the concrete, you don't have the problem of transmitting the signals. And all the signal is collected to a gateway that brings to a unique point that is used then to analyze the data and to understand how the concrete is hardening. And in this way, you can control also the timing of the operational system you have in a construction site, or especially also in the precasting structures. Just let's take a look to this example in Australia of a bridge that is precasting, prefabricated. And here the company has saved a lot of time using these sensors. Just let's take a look to a sort of.
We save 2 hours per day by using Converge over the conventional means of crushing cylinders. It's a cloud database in the online system is head and shoulders above its competitors. We're using precast segments to construct a bridge over the Swan River crossing in Fremantle. We had to make sure that we could strip the next day in order to keep our program on schedule.
The daily use of the platform and the technology has been instrumental in driving the production to be as efficient as it can be.
We were able to get real-time readings on the maturity estimated strength, and that allowed us to not have to wait for the conventional means of cylinder crushing. The thermal report The conventional method would have been a lot of spreadsheet work. With the Converge app, it created those graphs for us. Easy as clicking one button on the app and it outputted a report for all sensors. Surface finish was.
As you see, I can have the real data in real time about the hardening process of the concrete, just using my iPhone or mobile and using an application, smart and simple application. This means that I can have continuously data, and this helps to create then a big amount of data that can help a predictive AI that at this point can help contractors to choose also the better concrete mix, because time after time you can control and you can see which one of the mixed concretes that you have prepared and used works better, and you can change at that point also the mix design of the concrete, make little changes that can bring to different results, and this means save money, save time, and have a better material at the end, and have the possibility to continuously measure and control the quality and the characteristics of the material in time. Another really useful and that I'm sure every one of you knows very well is RFID system. Is the classic. This one fell down from the book I brought yesterday from a library. It's something that we already know in the everyday life, because they are systems that are put everywhere in the materials, in different things we buy, and etc. So it's a technology that is really cheap, there is everywhere in our life. But what happens and what changes is it can be also used in the concrete. These are elements that can be put inside the concrete, so you can have a kind of passport of the material, especially when you consider the construction not as a product but as a life cycle product. That means that you can have a passport of the concrete that you are pouring and putting in place from the first day to the last one, when you will imagine and we will come the moment to maybe to demolish or to intervene or to dismantle the structure, etc. It means that you are completely completely under control the life cycle of the material. Okay, and it can be, of course, in every moment read, and I can take all the information that I need continuously. I can monitor the system, of course, in distance, and it means that I have always the control on the structure, even not being there. This means a very cheap and very economical system to control. The same, you are young and maybe someone of you already works as a site manager. You know that when you pour concrete, you have to take the samples, and this system, for example, permits to work with the RFID tag system to sign every cube of concrete that you use for the samples and for the testing that you have to do, and you are obliged to do for a new structure. That means that you can have a really cheap and good system to control all the process, okay, and to name every small part, every small cube of concrete that you will have to control then, and to get documented at the end of the process of the construction. Another different system is that of controlling the cracks. That is, of course, something not new. Even that one is quite an old system to control the cracks of structure, and especially in the concrete structures. But what is happening is that it is becoming more and more easy to use, as you see here, and more precise. We are talking about 1,000, 3,000ths of millimeter of movement. It means that is a sensor that can feel movement that is really, really, really small. This means that I can control very well in time and have continuous data about the system that helps me to control and to manage the process, just trying to understand how it goes in time also, not only having time after time data about what is happening to the structure, but also how I can manage the next step. How can I plan the operations that I need to maintain the structure in efficiency. Here you see other similar systems that help to monitor digitally bridges or structures, and they are different sensors, always that has to do with a strain or simply feeling the movement or monitoring the expansion of the structure, and other parameters that are really useful to have an idea in real time, continuously, and with all the data connected and collected and analyzed automatically, as it is, for example, in this other high building, where a certain number of sensors can give the possibility to have continuously data about how the system is working, how is the health status of the structure, which is the structural maintenance that I need to plan, and how to develop and repair eventually problems or damages or parts of the structure. Here you see in real time what happens. Having more than 200 sensors in all the building, is a 200 meters high building in Dubai that is helped with the sensors, and what we see is how the construction is behaving in every moment, because the sensor, of course, the movement you see is exaggerated and is amplified, but it is exactly what happens to the building also, and even only from the wind that goes over the facade. So all the systems, as you can see, can be put together. And for more, the other part that I would like to show briefly and quickly is the robotic inspection. We need to see, and we will have the occasion in Ivrea this summer to go around a real building to see how the assessment is important, to understand the health level of a construction, and which are the problems, the real problems that it faces of losing the properties of concrete, cracking phenomena, or other problems that building might have. And all this can be already done also by robotic system, small, cheap, and really smart systems. Some of these are, for example, really, really simple, and they are becoming more and more present and smaller, that can be used really without big problems. Here, for example, you see one of the systems that are nothing more than a small drone, but it is used really in a very particular way. And you see it can go up to a wall, and it can bring me visual control over the surface, where I need to go with stairs, with scaffolding, with other complicated systems that are also not often so safe for the persons that have to, or for the technician that has to go to the construction site. And the same way, you see there are other similar small robots that go over vertical surfaces and can give us a good idea of how the deterioration problems are exactly happening and how and where they are happening. So I can map and I can have good information about a structure without risking to go up and using really, this is another strange thing. Elisabetta is looking in a strange way. I think you know how the Jacob's legs can be able to put this animal and to make him able to stay in a horizontal surface down and to have a weight. He can stay in very smooth and particular surfaces with upside down, with the head down, and all is possible because at his brushes or bristles at his legs are milliards, trillions of small parts that work with van der Waals forces that are really small intramolecular or atomic forces. And that means that a gecko can stay and can stay over vertical or horizontal surfaces without problems. And this is something that was really hard to understand from the scientists. And now they are able to repeat this with the nanotechnologies, because when we are able to rebuild this kind of surface made of thousands and thousands of small, very, very small and nanometric brushes, it works a lot, and we can use, and here we see one of the systems that use this this principle. And of course, is not something magnetic or something that works with the Ventosa system. This is the same way the gecko goes over the walls and the vertical surfaces. That means another small revolution that permits to go everywhere and to put an instrument near to the surface. Just imagine you have to create and to have a good imaging of an existing concrete building, and you can go everywhere in every part of the construction without big problems and have all the data, especially visual data, but not only, and analyzing micro cracks or other small problems that can be, of course, detected with this system or similar systems like that. And of course, these are systems that in some cases, here you have a really good case in Italy. The Morandi Bridge was a bridge that fell down some years before in Italy. It was really a tragedy because 42 people died in the falling down of this old structure, and it has been rebuilt completely new. It's a Renzo Piano project, and of course it's a mixed structure, concrete and steel. But what is particular in the structure is that it is monitored by a lot of sensors that are put everywhere in the structure, and in real time, continuously, there is a lot of data collected from these sensors, and the health situation of the structure is monitored 24 hours per day. And not only, you see in the images some robotic sliding arms that are used to visual inspection that is done day by day, taking pictures with a very high definition and seeing and watching the structure, collecting this data and analyzing it automatically to see if the surface has any problem, if the structure itself has strained particular conditions, etc. And all this is another good example how the different technologies are put together and integrated in a kind of BIM modeling I'm going to talk something about after. So what we have using these technologies is especially also with the drone technology, aerial inspection. That means I can go over the surface of a structure, but I can go also near with the drones and go everywhere. We are going to see it in this summer with Professor Korai, and maybe with my small drone. I'll bring it too, so we can see how we can manage it. And I'm sure that you are all young and good on doing this. If I'm able to do it, it means that you can do it in 5 minutes. We are going to show how to use them if you are not already skilled in that. and how they can be really useful on mapping and assessing the concrete structures, and have, of course, a lot of data that can be really easily collected. Here you see a short example of how you can control with very small drones. Just imagine that we are talking about small machines, small robots that are becoming less than 10 centimeters. Just imagine something really small, an insect that goes around everywhere and can collect a lot of precious data for managing existing structures. Okay. I have in mind the structure, the wonderful structure of the Torino Esposizioni. If I want to inspect and to see better near the surface, the very big surface, with small instruments like that, I can go near there, have a lot of big and high fidelity photos, and a lot of data that I can analyze without risking or without putting a scaffolding, a giant scaffolding inside the hole just to reach a certain point. It means saving a lot of time and money. And these systems are more and more integrated. Here you see another version of the drones that can also be used.
Visual inspections, data is what matters. So we've placed Ilios 2's payload in the front cage opening, fitted with a thermal and a 4K camera side by side. 12 megapixel still and video recording gives you stunning detailed images with 0.18 millimeters per pixel resolution to spot the tiniest cracks from floor to ceiling. The Ilios 2 features the most powerful and intelligent lighting system ever built on a commercial drone. 10,000 lumens of light give you an increased situational awareness in large spaces. Indirect dust-proof lighting allows you to traverse dirty places without losing sight of your objective. Detecting pitting and cracks has never been easier. An oblique lighting mode reveals the texture of surfaces by creating shadows in all asperities. Because failure is not an option, a robust working. When it comes to certified visual inspections,
you see here some situations where what we call normally in the construction site, especially when we deal with safety issues, the constraint or the small places. This is something that you will see there is always present when you go to an existing building. There are always parts of the building that are really not so easy to reach and to go near and to inspect the situation and to see the problems that the structure is facing. So the drone technology is something really helpful that can help us have a better precision, to save a lot of time, and to collect data to have then a really good control over the process. Another things that seems completely different and not related to the other parts is the cutting technologies. It has nothing new, especially because the cutting technology is something that is used from a lot of years. But what is happening now is that even this technology is being more and more integrated to a BIM system, and it is becoming part of a digital system that can be controlled in distance, and with which I can deal and I can decide which part of the concrete surface go and cut and clean or prepare for reparation or for other maintaining operations. Here you see two images. We will deal with that in the next summer in Ivrea, and Irene will will repeat more and more times that you don't have to repair, as you see here in this image, with a trowel, the classic worker that repairs an existing structure without cutting the edges, but just leaving these feathered wedges and doing something wrong that technically is not good. with the digital hydrodemolition, you can decide where to cut the concrete surface, which part of the skin of the concrete structure you can take off, and this can be done in distance with safe systems and also with really precise and controlled systems.
Hydrodemolition is a method to remove concrete to a quality depth using high pressure water. We call it ACR, automated concrete removal. The robot is powered by a high pressure pump that delivers the water to the tip of the high pressure lance, where the water flow and nozzle size determine the working pressure. The operator sets the working parameters, positions the robot, and starts the hydrodemolition process. The operator then monitors the progress at a safe distance. Changes to the sequence are made from the handheld radio remote control box or the display on the robot. The communication with the robot is wireless, and so is the communication with the pump. The automatic sequence, where the jet is moved over the surface at a constant pace, is constantly monitored while the data is transferred to the cloud for later retrieval through ConJet Connect. The water jet penetrates the porosities and cracks in the concrete, creating an overpressure inside. When the overpressure exceeds the tensile strength, the concrete blows out. No harm is done to the remaining rebars and no microcracks are formed by the method. It creates an ideal surface for bonding of new concrete, while the robot secures the quality and consistency of the concrete removal process.
Again, I repeat, here we have an old technology, but what is new now is that it can be controlled, and the form, the place, the part of the structure that I have to remove, because it is not anymore able to maintain and to protect the steel bars, the steel reinforcement bar. It means that it can be controlled digitally, and I can cut where I want with a big, really big precision, and with a easy way to put it in practice. Here you see one of the smallest systems that can be controlled digitally, and I can decide in a 3D model of the construction where to cut and where to intervene, what to take off on the surfaces, decide the surface, and the machine goes automatically and cleans the part that I have asked for. That means that I have to avoid a lot of workforce, a lot of hard work to be done, and often a work that is not so well done, because when I go with a sledgehammer, I will always have micro cracks and problems, and structural bondage will never be so good. With a hydrodemolition, I can guarantee more and better the quality of the surface that I'm going to bond and to use to putting over a new material. So all these things are, of course, coming nearer and nearer, and at the same way, some smart materials are coming out. The concrete itself, that seems the most easy and the most simple material in the world, is becoming more and more complicated, but also more and more good or better, because we are beginning to think how to use different nanomaterials. For example, here you see some of these examples. The trichoderma is a kind of fungus that can be utilized, putting it inside the concrete mix, and when we have the first moments of the moisture, the water that brings and goes inside and touches the steel rebars, the process is that of creating a kind of compression in different materials that become a kind of self-healing system that closes the micro cracks, and this means a longer lifetime of the structure, of course. And there are a lot of experimentations now on this theme. Of course, we are still at the beginning. Just to have an idea, that is a lot of research about that, and also about the graphene. Of course, will be one of the future materials. There is already some experimenting about the concrete that is concrete, where we put inside the graphene that can be also a material that transforms not only the characteristics, the properties of the concrete, but also can make it a connected material very easily. And the same way, nanoparticles or other similar materials that are changing and making the concrete more and more a complex material. That important, of course, is to know all these technologies and to understand how they will be more and more present in the everyday life. Because, of course, some of the things that I showed to you are still experimenting in an experimenting phase, but they are becoming more and more easy to use and cheaper, and we will find them in the next years in the construction. And just the last point I want to stress, and I think Cora is already connected to us, Irene, Professor Cora, that will.
Yes, he's here.
Yes, I am here, but please go ahead.
Okay.
Hi, Gaz.
Hi. And what brings together all these technologies is what I told at the very beginning. They are put together, and the best way, or the point where they can be collected and connected, is, for example, the BIM model. But especially considering BIM, Koray will explain it much more better than me. BIM is not a software. BIM is a methodology, and often, especially in Italy, my experience in Italy says that BIM often is seen as a kind of duty, as something that you are obliged to do for a tender, for a public tender, etc., but not as a working method. In the construction side, a lot of times BIM is not still yet working, because it is prepared, it is present, but it is not used from the craftsman, from the foreman, from the site manager. They don't use the data, they don't collect and put inside other data, as it has to be done in a really good system that works based on the BIM method. And but I leave the floor to you about that. What I wanted to stress is that the digital twins that are the obvious and natural consequence of the BIM method are really good on helping to have strategic outputs and to understand which is the remaining service life of a construction, for example, and how to plan the monitoring and the maintaining in time. It has to do a lot of with the money that we have to spend about the existing structures, and this is really something important, because it sometimes it decides the life and the existence of these buildings that we are dealing with. So just to close, keep in mind that more and more we're having a holistic integration about all these very different technologies that become all one thing, and of course they are still to be managed carefully, because we have to find and to understand that we have to put money for sensors or other digital systems, but we have also to understand which is the right point, and to have a good return of investment of what we are putting, how money we are putting, and what we are having back in real terms, in practical terms. And of course, all this, what I presented to you, is still on job, is something that is, let's say, moving on day by day. So all of us have to be careful and to look what is happening and what's going to happen in the future with the technology, and especially what is related to the concrete structures. Thank you.